In Gothenburg, the Danish contractor Pihl and Sons are doing a large civil structure for the Swedish railways. The project has developed into an exciting demonstration of how companies in the civil construction business can benefit from digital building information modeling, or BIM.
We are now standing in the center of Gothenburg, where Pihl and Sons are now erecting 2 new bridges that will lead 2 new railway tracks through Gothenburg. We are just now completing what we call Stage 1. That is the first bridge of 12, and as we can see, the reinforcement work is ongoing.
Research and development engineer Stefan Brandt Johansen is responsible for the first part of the project, initially working from the Pihl headquarters in Lyngby, Denmark. In order to handle the high complex geometry of the reinforcement, Pihl has chosen to do a digital model of the whole project.
The model has been done with the software Tekla Structures. The model is fully parametric, so we can easily and quickly create the structure once we have received the design from the consultant. We can also quickly do changes when they occur. At the same time, the model is central to the collaboration with the other participants in the project, and not least, procurement and fabrication of the reinforcement that is delivered to the site.
The BIM model has proven to be of great value for the collaboration between Pihl and Celsa Steel Service in Halmstad, Sweden, who is delivering the reinforcement for this project.
Once the concrete structure has been modeled, we have also put the reinforcement in the Tekla Structures model. As you can see here, the rebar are very close to each other, and in combination with the tension cables, this has proven to be quite a challenge. We have used the model to do collision checking and have solved the geometric challenges this way. It was key to us to be able to create a digital flow of the reinforcement data directly to the manufacturer. This has been done by creating a link to the ERP software that Celsa uses to control their production. The way it works is that you simply mark up the reinforcement you want to order, open the link, and export a file that contains all the needed data. This file is then sent to Celsa, who uses it directly for automatic production.
Sendes direkte til Celsa, som de producerer efter. Og det er den her informationen vi får fra BIM.
This is the information that we get from BIM, which is printed out. Here is all the information that we need. Number of rebar, size, cutting length, weight, and all the measurements, including angle and radius. This data we simply read into our computer.
The information is read into the robots so that the reinforcement is cut and bent 100% accurately. The cut and bent reinforcement is bundled, marked with tags, and shipped to the construction site. The traditional way of pre-cutting and bending, based on the information derived from 2D drawings, is often error-prone, especially in projects with complex reinforcement. The errors then need to be corrected on site, which costs both time and money. However, in the Gothenburg project, this is no longer the case.
Here we see the site cutting and bending workshop, and we have some rebar in different sizes that we use. It is, however, rarely needed in this case, which is due to the fact that the reinforcement we order via the model is correct, and we don't have to do a lot of cutting and bending here on site. Naturally, the waste of material is vastly reduced.
The 3D visualizations from the BIM model is a big help, both in production meetings and on the construction site.
It is much easier for the guys to understand when you can show them a picture of the model. They are no longer debating whether it is actually possible to do, which would normally take time from the project, and that is of big value to us. Now the guys start working with a positive attitude, because it is clear to them that the work is possible to do. Everyone has the picture of the model in mind.
BIM has proven to add even more value to the project than Pihl had originally expected.
In the first of 12 stages of the project, which was done in the old way of working, there were about 20 to 25 errors in the reinforcement delivered on site. The errors came from the procurement that was based on the old 2D drawings, which made it very hard to determine the sizes and numbers. That caused us to do a lot of cutting and bending on site. In the following stages, done with the new way of working, we are now down to 0 to 2 errors. We have reduced the number of errors to a minimum by doing class checks and solving all the issues in collaboration with the consultants before starting the work on site. We have also reduced the work hours needed for this project considerably. The first stage took 23 workdays just to complete the reinforcement work. The use of this new technology has contributed greatly to the fact that we are now completing the same work in 7 to 9 days.
Til at vi nu nede på en produktionstid på brodækkene på 7, 8, 9 arbejdsdage.
This means that the production time has been reduced by 2/3 compared to the first stage. The first stage was done during the winter, so all the time saved can't be contributed to BIM alone, but there is no doubt that most of the reduction in time and errors is due to BIM.
The understanding of the value of BIM is now starting to spread to the rest of the organization. We see other site managers contacting us to get help, and of course this shows us that the project has been an even bigger success than we had expected.
The people involved in the project agree that it is important to have a dedicated BIM consultant that can aid the site people when taking on BIM for the first time.
Initially, we thought that we didn't need Stefan to do this project, but he has helped us a lot, and now we have a much better understanding about how this works. I think you did a great job, Stefan.
Read more about the project on our website.